This is the solution to question 3 for HAP 725, Statistical Process Improvement. The solution was provided by Dr. Maria Uriyo. In this assignment, examine if payments for AMI have declined over 4 time periods. Keep in mind that start and end periods are also given inside the files, and that these do not correspond to the database reporting year. Also note that the name of the variables and file names change over the years. So make sure that you download data for every year the measure for AMI is available for all available hospitals. In these files, the denominator indicates the number of patients, and payment indicates the average payment per patient. You are to select data for hospitals that had at least 100 patients, and then towards the end, you are to submit the control chart for the data. Data files were obtained from the Hospital Compare website. The URL for the website is shown below. In addition, you only need to extract data from 4 time periods. So this table on this slide shows you the name of the data files as well as the measure that we're looking for. An X-bar chart will be used for this problem. The assumptions that need to be met for using the X-bar chart are that payment is a continuous scale, patients are independent from each other, and the data has to have a normal distribution. Now, the determination of how to determine to create this histogram will occur later on during the data transformation steps. And I'm showing you here that the grand average for data from 2011, 2013, 2012, and 2014 is about $23,000, which you can see is right in the middle of these histograms. We begin our analysis by importing libraries. We're going to be using 4 of them: Pandas, NumPy, Math, and Matplotlib. We then call the 4 data files that we're going to be using for this analysis. In this case, we're using data from 2011, 2012, 2013, and 2014. Notice that the data files are CSV, and so we're going to use the pd.read_csv function. In addition, once that data has been imported, you have to, at least good practice, to see what is inside that data set. So you do that by using this data frame data_2011.head. We are next going to create separate data frames with limited number of selected columns for each time period. We're going to limit the number of columns to the following: provider ID, hospital name, payment measure ID, denominator, payment, measure start date, and measure end date. In this step, we are going to find the number of rows and columns for the 4 data frames that we just created in the previous slide. Notice that we now have 7 columns instead of the 22 columns that we had in the original CSV file. Next, we determine the data type. Data type results from the 4 years show that the denominator and payment attributes need to be converted from object to float data type. In order to be able to do any calculations, they need to be float. In this slide, we're checking for non-numeric values in the payment column. We're using the 2011 year. The traceback feedback includes a value error and shows that it could not convert the $12,000 string to a float. You'll have to scroll towards the bottom to see what that value error final message is. You then need to remove the $sign and the comma using the str.replace for the payment column. This output shows that the $sign and the comma has been removed. However, the data type for payment is still an object. In addition, not available should not be an entry inside the payment column. It needs to be changed. Next, we convert the payment column to a float. We then replace the not available entries with a 0. The output shows that the payment column is now a float, and in addition, the not available entries have been replaced by a 0. This slide shows you how to convert the denominator column into a float. We are now ready to apply additional conditions that were given in the problem. So in this case, we are going to filter the data so that we have denominator that is 100 or more. The payment measure ID should be equal to payment 30 underscore AMI. And then we want also the payment should always be more than 0. This slide shows partial output from the step in the previous slide. In this step, we're determining the number of rows and columns from the filtered data frames. Average payment calculations across the 4 time periods are being done on this slide. We are creating a data frame containing payment information from 2011, 2012, 2013, and 2014, and then renaming those columns to payment 2011, payment 2012, payment 2013, and payment 2014. This slide shows that the data frame containing the payment information has a normal distribution. And this is important because it is one of the assumptions that you have to meet when you are determining the type of control chart you have to use. In this slide, we're determining the number of rows and columns as well as the type of data, the data type that is in the data frame. We are now ready to perform some calculations. We begin by determining the grand average from using the data frame that we just created. And then we look for the average payment per time period. And lastly, then we look for the standard deviation for all the data across the 4 years. In this slide, we need to find the count of hospitals in each year. Next, we need to find the standard deviation of each time period. And then, of course, the z-stat value that we'll use is 1.96. In this slide, the code for creating the data frame holding values that will support the calculation of the upper and lower control limit is shown. In this slide, we're creating a new data frame that has new column names. In addition, we're also going to check the data types for the new data frame. This slide shows the calculation of the upper and lower columns. The code for plotting the X-bar control chart is shown on this slide. The chart indicates that net payments to hospitals for AMI is increasing. In 2011, average payments were lowest and below the lower control limit. Such a low payment was not due to chance. Over the next 2 years, payments increased but fell within the upper and lower control limits, reflective of outcome based on chance. The real change in average payment occurred in 2014. This change is not due to chance. Thus, payment reform has resulted in increased net payments to hospitals for AMI treatment. Numerous carve-outs for never events have not been a negative issue.